In this video, we'll review how to solve single variable inequalities and graph the solutions. To begin, let's recall some inequality symbols. These are our inequality symbols. We have the greater than symbol, the less than symbol, the greater than or equal to, and less than or equal to symbols, which are denoted by the little line or the or equal below. Now, when we graph the solutions, we've got to keep in mind that sometimes we'll have open and closed points. That'll depend whether it's just greater than, or less than, or greater than or equal to, and less than or equal to. The ones that have the or equal to have the closed dot, or closed point. So the first one here, greater than, that's going to be an open point. For example, if we say x is greater than 3. When we do this on a number line, we're going to have an open point at 3 because our solutions are any number that is greater than 3. So not 3, but any number greater than it. So we use the open dot to show that that is not a solution. Only the values that are greater than 3. And to show that we want the solutions greater than 3, we'll now shade to the right of 3. Because those numbers, 4, 5, 6, 7, and even decimals, 3.1, 3.2, and so on, are going to be greater than 3. Now here's another one, less than. Less than will also have an open point. For example, x is less than negative 1. The only solutions are the numbers that are less than negative 1. So not negative 1, but any number smaller than it. So again, we'll use an open point here at negative 1. And now we want numbers that are less than negative 1, which would be to the left on the number line. Negative 2, negative 3, negative 3.1, and so on. So we'll shade to the left. Now when we have the or equals, those will use the closed point. So for instance, if we say x is greater than or equal to negative 2, we'll use the closed point because that will tell us that negative 2 is one of the solution and any number that is greater than it. So when we do this on the number line, the difference is we're going to have a closed point here, and now we'll shade to the right, indicating that we want numbers that are greater or equal to negative 2. Another example for less than or equal to would be x is less than or equal to 0. Here, we'll put a closed point at 0, and to show that we have numbers that are 0 or less than 0, we will use the closed point, saying that 0 is a solution, and shade to the left to indicate that we want numbers also that can be smaller than 0. Now let's look at some examples. I've got two other problems that look very similar to last ones, except that we notice the variable's now on the right-hand side. If the variable's on the right-hand side, we're going to have to rewrite the problem. This first one says 6 is less than x. When we rewrite it, we really want the variable on the left-hand side. When I rewrite it, I see that 6 is less than x. So when I rewrite it, I'm going to say x is now greater than 6. Now notice, the symbol. X is greater in both cases, so we need to make sure that when we flip the problem around, that we flip the symbol to indicate that x is still greater. Now this makes it a little bit easier for us to graph because we know that we want numbers that are larger than 6. So open point at 6, and then numbers that are greater. We want to make sure that we write the variable on the left-hand side because it helps us to understand which way we should be shading. Now for the next one, we have negative 2 is greater than or equal to g. The negative 2 is larger than g, or equal. When we rewrite it, we want to say that the negative 2 is still greater, or that g is less than or equal to negative 2. So rewriting the problem means we'll rewrite the symbol, flip it, and well, we have g is less than or equal to negative 2. Now when we shade this, we have the closed point because we have the or equal, and we want values now that you can see that are going to be less than or equal to it. So we'll shade to the left. Now here's some examples of single-step inequalities. To solve these, we're going to have to isolate the variable and make sure that we have x on the left-hand side. So for the first two problems are going to be pretty quick. Now if I look at problems 3 and 4, I'm noticing that the x is on the wrong side, which means at the end I'll probably have to flip it around. So here we go. For number 1, I have x plus 2 is less than 1. The inverse of adding 2 would be to subtract 2, so I'll do it like I would solve an equation. I will subtract 2 from each side of the inequality. The 2 and the negative 2 cancel, and it leaves me x is less than 1 minus 2, which is negative 1. My solution is x is less than negative 1. When I go to graph this, I'll have an open point at negative 1, and then shade to the left, indicating that I want numbers less than negative 1. Now for example 2, we have x minus 8 is greater than 4. The inverse of subtracting 8 would be to add 8, so I'll add 8 to both sides of the inequality. The 8's cancel, and I get x is greater than 4 plus 8, which is 12. My solution is x is greater than 12. We'll use an open point, denoting that we want numbers that are only larger than 12, and then shade to the right. For example 3, I notice the x is on the wrong side. So I'm going to go and solve it anyway, and then when I'm done, I'll just rewrite it. So here, with the x, we have the minus 7. In order to be able to isolate the variable, we'll have to use the inverse of subtracting 7. The inverse of subtracting 7 is to add 7, so we'll do that to both sides of the inequality. Negative 2 plus 7 is 5, and we get 5 is greater than or equal to x. Rewriting the problem, 5 was greater, which means x is less than or equal. So here, x is less than or equal to 5. Because we have the or equal, we'll use a closed point, and now we see that we want values that are less than or equal, which means to the left. For number 4, here we've got 9 is less than or equal to x plus 6. On the side with x, we're adding 6. The inverse of adding 6 would be to subtract 6, so we'll do that from both sides. 9 minus 6 is 3, and we get 3 is less than or equal to x. X is greater than or equal to 3, so when we write it, we need to show that. X is greater than or equal to 3. On this problem, when we go to shade, we're going to use a closed point at 3, and now x is greater than or equal to 3, which means we need to shade to the right. Values that are greater than or equal to 3. Now, for the next part, we're going to have to worry about what's the rules for when you multiply and divide, and there's some differences here. When we add and subtract, we never have to worry about reversing the symbols. However, let's look at them when we multiply here. I've got a problem that starts with 4 is greater than 1. 4 is a larger number than 1. Now what I'm going to do is I'm going to do some operations of multiplication, and I'm going to do it to both sides of my inequality, and I want to see what happens to the symbol. So to start with, we're going to take our 4 and 1, and we're going to multiply both sides by 3. 4 times 3 is 12, 1 times 3 is 3, and 12 is still greater than 3. So we'll put a greater than symbol. What if we multiply both sides by 2? 4 times 2 would be 8, 1 times 2 is 2, 8 is still greater than 2. If we multiply both sides by 1, 4 times 1 is 4, 1 times 1 is 1, 4 is still greater than 1. What if we multiply by 0 on both sides? 4 times 0 is 0, but 1 times 0 is also 0. 0 is no longer greater than 0, it's now equal. What if we multiply both sides by negative 1? 4 times negative 1 is negative 4, 1 times negative 1 is negative 1, but now negative 4 is less than negative 1. We need the other symbol. Multiply both sides by negative 2. 4 times negative 2 is negative 8, 1 times negative 2 is negative 2. Now we get negative 8 is less than negative 2. And one more here, let's multiply both sides by negative 3. 4 times negative 3 is now negative 12, 1 times negative 3 is negative 3, and we get negative 12 should now be less than negative 3. So what's the conclusions here? Notice that when we multiplied both sides by a positive number, the symbol didn't change. There's no change when we multiply by a positive. If we multiplied both sides by 0, we notice that we got 0 equals 0. In that case, it's equal. It just becomes an equation. 0 equals 0. It's kind of a one we don't use very often. But what happens when we multiplied by a negative? This is where I really want to focus for a moment. When we multiplied both sides by a negative, whether it be negative 1, negative 2, negative 3, we notice that the symbol reverses. So here's the rule. You've got to keep in mind that when you're solving an inequality, anytime you multiply or divide even by a negative number, you're going to need to reverse the inequality symbol. This means that we have the opposite values, which means the opposite symbols. So let's look at this. Here's some more single-step problems, but now we're going to have to use multiplication and division. All right, let's take a look. Problem number 1. We have 7x is less than or equal to negative 49. Now notice that the 7, the coefficient of x, is positive. So when we divide both sides by 7, the inverse of multiplying by 7, we're not going to change the symbol because we're dividing by a positive. Even though the negative 49 is negative, it doesn't matter. The value that's with x is the value that we're undoing, and because it's positive, it'll just stay the same symbol. We get x is less than or equal to negative 7. Symbol stays. We're going to go ahead and shade this using a closed point because it's or equal, and shading to the left. Now for example 2, here we've got x over 3 is greater than negative 2. Well, that x over 3 is really x divided by 3. The inverse of dividing by 3 is multiplying by 3. So we'll say that x is greater than negative 6 once we multiply both sides by positive 3. So if we multiply by 3, 3's cancel, and we get x is greater than negative 6. The symbol did not reverse because the value that was with x originally, the one we had to undo, was a positive value. When we shade, we'll use an open point, and now we'll shade to the right. Numbers that are greater than negative 6. For number 3, We'll go ahead and divide both sides by 2. Dividing by a positive does not change the symbol, so we get 20 is less than x. Notice, however, that x is on the wrong side. We tend to want the variable on the left-hand side when we have inequalities, so when we reverse it, we'll reverse the symbol. Notice that the 20 is greater, and the x is less. So when we rewrite it, it's x is less than 20. Open dot and shade to the left. Last one. We're going to have to divide this one because we have negative 9x is greater than 27. When we divide both sides by negative, this is where we're going to reverse the symbol. We're undoing negative 9 times x, which means we got to divide by a negative. When you divide by a negative, you're taking the opposite value, which means you use the opposite symbol. Here, x is now less than negative 3. So open point and shade to the left. Now let's look at a couple multi-step examples. For example 1, I've got 2x plus 1 is less than negative 9. We're going to undo this the same way we do equations. We tend to undo our order of operations in reverse order, which means we'll have to add or subtract and then multiply or divide. So to begin, we subtract both negative 1 from both sides. We get 2x is less than negative 10. Divide both sides by 2, and x is less than negative 5. Open point and shade to the left. The next example. Here we've got the variable on the right side, which means at the end we're going to reverse it. We'll start by subtracting 5 from both sides, and then dividing both sides by 4. We get 4 is less than or equal to b, and then we rewrite it. Now b is greater than or equal to 4. Close point at 4, and shade to the right. Let's look at 2 more examples. Here we've got a distribution problem. We've got 2 times the quantity t plus 2 is greater than or equal to 10. Now we have the 2 ways we could do this. We could distribute, or we could start by dividing both sides by 2. It doesn't really matter. Let's distribute 2 times t and 2 times 2. 2 times t is 2t, and 2 times 2 is 4. So we get 2t plus 4 is greater than or equal to 10. Subtracting 4, and then dividing by 2, we get t is greater than or equal to 3. Now if we divided by 2 first, we would have got t plus 2 is greater than or equal to 5, and then subtracting 2 from both sides, we would have got the same answer. T is still greater than or equal to 3. So close point and shade to the right. For our last example, we got variables on both sides. We need to choose one side to move them to. Now because we want the variable to the left, it's natural just to move the n to the left-hand side. So we'll subtract n from both sides. This gives us 2n plus 2 is greater than negative 8. We'll now subtract 2 from both sides, divide by 2, and we get n is greater than negative 5. Notice we didn't reverse the symbol because this way we did it, the coefficient of n was positive. So we divided by a positive, it doesn't change the symbol. Open point and shade to the right. Alright, for these 4 examples, I'd like for you to pause the video, work them out, and then check your answers. I'll give you a moment. Alright, hopefully you've had a chance to work these out. For the first one, we're going to subtract 7 from both sides, and then divide both sides by 5. We get y is less than or equal to negative 2, open point, shaded to the left. For the next one, x is on the right-hand side, which means we'll reverse it at the end. We'll start by subtracting 8 from both sides, and then dividing both sides by negative 3. Because we're dividing by negative, we'll flip the symbol. And we're going to flip it again when we rewrite x to the left-hand side. This is the open point, and shaded to the left where x is less than 8. For the next one, we'll subtract 5 from both sides, but then have to divide by a negative. Dividing by a negative 2 means we're going to reverse the symbol. D is now less than 0. Open point, shade to the left. For the next one, we could start by dividing by negative 1 by both sides, or we could distribute the negative. Let's distribute. We'll now add 3 to both sides, but then have to divide by negative 1. We're going to flip the symbol. Open point, shade to the right. Alright, thank you for watching this video, and hopefully it helps you to understand how to solve and graph single variable inequalities.